taking the electronic configurations of ions, let me go for iron plus 2. This is called ferrous ion, right? Now, how to write the electronic configuration of Fe plus 2? We know that the electronic configuration of iron, the atomic number of iron is 26. Coming to its electronic configuration, let us write it clear. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Hope you all know how to write NLX method of configuration. Now coming to this, you got valence shell, you got the penultimate shell, of course with more energy than 4s-Ag3d, and this is of course anti-penultimate shell. Remember, while removing electrons, see what does this plus 2 refer to? Plus 2 refers to the thing that it has lost 2 electrons, right? From where iron has lost its 2 electrons? Remember, it is not from 3d, but it is from 4s, the valence shell. Now these 2 electrons are lost. This is something interesting. So the formula of iron plus 2 will be, the electronic configuration of iron plus 2 will be 1s2, 2s2, 2p6, say 3s2, 3p6, and then 3d6. Now if you consider this, remaining all, the 1s, the 2s2, 2p6, and the 3s2, 3p6. All these are completely filled. You don't have any unpaired electron. You all know that. If you want, I'll show. 1s2, 2s2, 2p6, then 3s2, then of course 3p6. Three D6, 5, now pairing up. So how many unpaired electrons are there? Even this also forms an important point. The number of unpaired electrons is 4. A basic information. I am not going into the details of all this. Only thing that I am discussing is the electronic configuration. Of course, we'll go for so much of information on this in atomic structure, in periodic table, even in chemical bond also. We'll go for all these things again and again in all these 3 topics. But for now, I just wanted to tell you that the electrons are lost from 4s, not from 3d. And now suppose if you take the configuration iron plus 3, what would it be? obviously, let me first write the configuration of iron. Will then remove 3 electrons. Right. Now, because it is +3, let me just remove electrons. I mean, first these 2, then 1 electron from this, and I'll be left with 5 electrons. So the configuration, this is the configuration of iron. Now for iron +3, the configuration is going to be 1s2, 2s2, 2p6, 3s2, 3p6. Then this, of course, is 3d5. This is the configuration of iron +3, right? And remember, let me just give you one more information before concluding. If suppose you consider the atomic number and mass number of iron, so iron is given as 2656. Now coming to the number of protons, electrons, and neutrons in this, how do you write? Come on, number of protons, of course, is equal to atomic number. Clearly visible. Of course, the number of electrons is also equal to atomic number, but only in case of neutral species. Now, this is not a neutral species. You got something which is charged. Charged, not a neutral one. So in case of charged species, let me just make it little more special. Come on, write down 26, and the +3 refers to the thing that it has lost, 3 electrons. So this is very important here. And as usual, the number of neutrons can be written as, it is common, 56 minus 26. Simple, A minus Z, right? So this is interesting. Only the number of electrons changes when something gets converted into its ion. There won't be any change in the number of protons or neutrons. Is that okay? Even this also is very important when you go for writing the electronic configuration of ions, especially in case of those which consist of electrons in 3D sublevel. Remember, electrons are first removed from 4s, then only from 3D. This is very important. Number of unpaired electrons in this can be given as five, isn't it? 3D5 configuration can of course be represented as this one. This is all about writing the electronic configuration of ions, finding the number of protons, electrons, and neutrons, of course, the number of unpaired electrons.